Good evening, ladies and gentlemen. Welcome to the latest instance in the Open Source Developers at Google Speaker Series. Our speaker series is designed to help the public understand more about what some of the open sourcers here at Google are doing in their time here at Google. And I am pleased this evening to introduce Charles Chen and TV Raman, both of whom share an office here and work on accessibility issues. And these gentlemen tonight will be discussing enhancing Web 2.0 accessibility via Access Jacks. Gentlemen, take it away.
Thank you, Leslie. Thanks for coming, everyone. It's a Monday evening. We really appreciate your showing up and taking the time to come for this talk. So my role in this talk will be to talk as little as possible and allow Charles to talk. So that's my challenge, and at the end you can grade me on how well I do. And Charles' challenge, of course, will be to talk without pausing so that I don't get a chance to cut in. So what we'll talk about is injecting accessibility and usability into Web 2.0 applications. The background for this work is that, as you know, if you take a look at the kinds of web application Google builds, we and other Web 2.0 developers have been, for the last few years, pushing the envelope on what can be done in the web browser. And the result has been extremely dynamic, highly interactive HTML interfaces that work very well, but in the past have also presented significant challenges to users with special needs. So, for instance, if you cannot see and you're using a screen reader or a talking browser, a lot of the AJAX applications caused no end of pain. We've been looking at this problem for the last 2 years or so, and we've basically gone down the route of asking how can we use the same AJAX technologies to enhance the usability of Web 2.0 applications for somebody who cannot see. The background for this work is something which is now in sort of W3C last call, or getting ready to W3C last call, called W3C ARIA, which is Accessible Rich Internet Applications. It's a spec, but the spec can be sort of summarized in half a dozen lines. If you think of HTML and JavaScript as the assembly language of the web, it's low-level assembly language. You're doing spans and divs and attaching event handlers and styling it. If you think of that as the assembly language, the way to conceptualize ARIA is that it's a couple of additional opcodes in that assembly language that helps adaptive technologies like screen readers and self-voicing browsers discover, introspect, reflect, and then provide the right feedback for the HTML widgets. That's a lot of words. Basically, in simple terms, it allows a screen reader to know that a menu is a menu and then treat it as such when you interact with that. What Charles and I have been building is, if you have this assembly language, now, when you write your AJAX app, you typically use a toolkit. You typically use Dojo or any other JavaScript library that you like, or in the case of Google, you might use GWT. And those things give you higher level design patterns to do your GUIs nicely. What we have created is an open source library that we call Access Jacks that allows you to do the same for good auditory user interfaces. All of the output that you will hear is actually produced by the screen reader, so we don't do the talking. We provide the web developer the right JavaScript calls to make the adaptive technology talk. For today's talk from here, when Charles takes over, he will show you everything running on a Mac. He is using Firefox, which is Charles's project. He started that as a student, and here at Google he is doing it on his 20% time. We are doing the demos, we are doing all of this today on the Mac because it's one of the best ETS engines that you can find out there today. So for that, I will hand it off to Charles, and Charles, from here on, you're supposed to prevent me from talking.
Okay. Thanks, Raman. So now I'd just like to add in a few other things about Access Jacks library. One of the key benefits of this library is that not only is it something that a web developer can use to improve their web page and enhance their usability, it's also something that a hacker, someone who's just really into coding, into doing things, open source developers, such as Office here, we can use this library and apply it to websites that aren't using it themselves. Because at the end of the day, this is just some JavaScript, and the JavaScript can be inserted into a web page through various mechanisms. For example, bookmarklets or GreaseMonkey. And so that's one of the key benefits here is that even if the web developer, even if you don't own the website, you can still enhance the usability and accessibility of that website using AccessJax. And so with that, I'm going to show you all a demo, and I believe that's the best way to show some of the benefits that you can get from using AccessJax. Now, before we use it, let's look at before and after scenario. So I'm going to do the before case first, and I am going to do a search for flowers on everyone's favorite search engine. Okay, so this brought up a page of results for flowers, and you'll see that we have results, we have sponsored links, we have related searches, and you have many pages of results that you can go to. Now, if you're trying to browse this with a screen reader and get through it, it's rather painful because although we have well-structured content, we have headings and section tags and all of that, it's still not that easy to navigate, because to go through the results, what you have to do is you have to say, take me to the next heading, or the first heading. So it's going to take you here to this first result. And all you will hear at this point is you will hear the title text. You won't hear any of the snippet content. So to determine whether or not this result is something that you want to click on, you're going to have to tell your screen reader to read the next bit. And when it reads the next bit, then you're going to hear the snippet. Now, if this is the link that you wish to click on, now you have to tell your screen reader to go to the previous heading to get back up to the link so that you can click it. And you just repeat this process until you go through all the results. If you need to go to the next page, then it's going to take several tabs. So you'll be tabbing for quite a bit here to get to the next link. And if you're a Power Screen Reader user, Power Google user, you probably know of a few shortcuts that can shorten this process, but still it's relatively painful. And then you also run into the problem of trying to group related items. So if you, say, brought up all the links on this page, and you got all the URLs, but then how do you differentiate between the sponsored links versus the results? I mean, they're all links to other pages here. So that sort of grouping, visually you look at it and it's obvious. All the sponsored links are to the side. All the results are centered to the left. But if you can't see and you're just trying to determine that, it becomes a little bit difficult. So let's see. Let's step back and think about what the eye is doing for you when you look at this page. So the eye is helping you group things, and it's allowing you to quickly scan the page and just look at the parts that you want to look at that are important to the task at hand. And so if the task at hand is that you want to do some research about flowers, then you want to look at the results. You'll see a Wikipedia link. You can click on that. If, on the other hand, the task that you're trying to accomplish is you want to order some flowers, then you probably want to look at the sponsored links to the right-hand side so you can order some. And so with that in mind, you can think of a busy page with a lot of content as a page with multiple lists of related items. And you should be able to switch